Now, good morning everyone. So, we will pick it up from where we left in the last session. That is, I think we had discussed ratio part 1, or rather we can say the first part of ratio. Today we will continue with the second part of ratio along with another part of ratio which is called proportion. Now, to talk about the second part of ratio, the first thing that I'd like to discuss is this particular thing called partnership. Now, what is exactly partnership? Now, partnership, according to according to the definition that is usually discussed in colleges, would be a little bit more complicated than the kind of partnership that we would indulge in. But in mathematics, or with respect to ratio, partnership actually indicates questions where we decide on the profit sharing, which depends on the capital invested and the time for which the capital was effective in the business. So basically, we can say that profit share is actually proportional to capital into time. So capital into time. Now this capital into time is nothing but we can call the time for which the money was in the business. Now let me share one example that would help you understand this concept in a better way. Say A starts a business. A starts a business with rupees 50,000. Okay. After 2 months, B joins with rupees 60,000. After 2 more months, C joins with rupees 1 lakh. 1 lakh. Then what would be C's share if the total profit earned is rupees 40,000 at the end of the year. Now, here in this question, we can easily see that A starts a business with 50,000. Now, after 2 months, B joins with rupees 60,000. Now, after 2 more months, C joins with rupees 1 lakh. So, if you look at it very carefully, there is one thing which is very clear, that A's money was there throughout the year, B's money was there for 10 months, I beg your pardon, and C's money was there for 8 months. Now, if you look at it very carefully, look at it this way. So, A's thing will be nothing but 50,000 into 12, that is the equivalent capital, which is nothing but, if you do the math, it's coming to 6 lakhs. B has invested 60,000, but the thing is applicable for 10 months because it was after 2 months. So this also comes to 6 lakhs. And C has 1 lakh, but it's valid for 8 months because after 2 more months. So that means if you look at it, so after 4 months C joins the business. So his capital is equivalent to 8 lakhs. Now, if we reduce these numbers, that means A is to B is to C, so the profit ratio would be, so the profit sharing ratio is nothing but 3:3:4. Because if I reduce this, if I cancel all the zeros, I have 6, 6 and 8, which is nothing but 3, 3 and 4. So the profit sharing ratio is 3:3:4. So the question is saying that what would be C's share if the total profit earned is rupees 40,000 at the end of the year. So obviously C's share would be nothing but 4 parts out of the total ratio, which is nothing but 3 plus 3 plus 4, which is 10. 4 by 10 of 40,000. If you do the math, it comes to how much? It comes to 16,000. It comes to 16,000. That's our answer. So C's share in this case would be 16,000. Now, if you were asked that what would be A's share would have been 3 over 10. That is 3 by 10 of 40,000, which is nothing but 12,000. The same thing goes for B, because A and B, they have the same ratio, that is 3:3. So 3:3:4 is the ratio in which the profit would be divided among A, B and C. So in this case, the answer comes to C's share would be 16,000 rupees. Here we have a question which also addresses the concept related to partnership. Now let's go through the question first. A, B, C start a venture investing 1 lakh each. After 2 months, A withdraws 20% of his capital. After 4 months, B withdraws 50% of his capital. After 6 months, C withdraws 80% of his capital but puts back 50% of the withdrawn amount at the end of 8 months. Find the profit sharing ratio between A, B, C at the end of the year. So whenever we come across questions like that, there's nothing to worry. The concept stays the same, that we need to figure out that how much money was active in the business and for how long. So here let us look at A's case. Now if you look at A's case, A had invested 1 lakh. So what has happened is, it is 1 lakh into 2, because it was active for 2 months, and then plus, because he had withdrawn 20% of the capital, that means 80,000 rupees was active for the remaining 10 months. So here we would straight away write this should be 2 lakhs and 80,000 into 10 is 8 lakhs. So basically it is 10 lakhs. Now let's look at B. B's 1 lakh was valid for 4 months and he withdraws 50% of his capital, so 50,000 was left in the business for the remaining 8 months. So if you do the math, 1 lakh into 4 is 4 lakhs and 8 into 50,000 is also 4 lakhs, so we have 8 lakhs. So his equivalent capital for the entire year is 8 lakhs. C. For C, the 1 lakh was there for the entire 6 months, and then what happens, he withdraws 80% of the capital. So obviously 20,000 was there, but here 20,000 was there for just 2 months, because at the end of the 8th month he pushes it back 50% of the withdrawn amount. That means he pushes back 40,000 into the business once more. So 40,000 plus the 20,000 that is already there gives 60,000 into, if you look at it for the remaining 4 months. So here if you look at it, it's 6 lakhs. We have 6 lakhs and we have what? 40,000, and this is nothing but 2,40,000. 2,40,000 plus 40 is 2,80,000. 2,80,000 plus 6 lakhs would be 8,80,000. That's the equivalent capital. Now if you have to take out the ratio of A is to B is to C, what do we have to do? Now we have to take out the ratio of these three values. Basically it is 100 is to 80 is to 88. Now if you do the math, so it would be 25 is to 20 is to 22. So the profit sharing ratio would be nothing but 25 is to 20 is to 22. Now let me explain this thing once again. See, A, B, C, all three had put in 1 lakh into the business. But what happened out here is 1 lakh was there for 2 months, because after 2 months, A withdraws 20%. Now 20% of 1 lakh is what? So here if it is 20% of 1 lakh is 20,000. If 20,000 is taken off, 80,000 is there in the business. So we have 80,000 into the remaining time, which is 10 months. So here the overall amount is equal to 10 lakhs, because 1 lakh into 2 is 2 lakhs and 80,000 into 10 is 8 lakhs. 2 plus 8 gives us 10 lakhs. Now let us look at B's case. Now after 4 months, B withdraws 50% of his capital. That means till the 4th month, 1 lakh was working in the business. So we have 1 lakh into 4, and for the remaining 8 months, 50% of the capital was active in the business, because he had withdrawn 50%. So 50,000, 50%, if 50% was withdrawn, 50% is left. 50% of the capital is 50,000. Now 50,000 was active for 8 months. Now 50,000 cross 8 gives us how much? 4 lakhs over here, and 1 lakh into 4 gives us another 4 lakhs. So 4 plus 4 gives us 8 lakhs. So we can say that the B's equivalent capital is 8 lakhs. Now let us look at C. Now C, if you look at it, after 6 months, C withdraws 80% of his capital. Means for 6 months, this 1 lakh was working in the business. Now that's the reason why we have 1 lakh into 6. Now let's look at it. If C withdraws 80%, 20% is left in the business. Now 20% of 1 lakh is how much? It is 20,000. So 20,000 should have been applicable for the active for the remaining 6 months, but if you look at the question, C withdraws 80% of his capital but puts back 50% of the withdrawn amount at the end of 8 months. That means this 20,000 is was there in the business for 2 months, because after 2 months, that is 6 plus 2, after 8 months, C puts in 50% of whatever he had withdrawn. So C actually puts in back 40,000. Because he had withdrawn how much? 80,000. 50% of 80,000 is 40,000. Now if he puts back 40,000 into the business, there was already 20,000 there. So 40 plus 20 gives us 60. So 60,000 is applicable for the remaining 4 months. So if you look at it, see 6 plus 2 plus 4, that accounts for the entire year. But we have what? 6 lakhs. Then we have 40,000. And then we have 2 lakh 40,000. So if we add up everything, we'll have 8 lakh 80,000. Excuse me. Now, to take out the ratio between A, B and C, what we need to do is to take out the ratio of these three numbers. If you do the math, it's coming to 25 is to 20 is to 22. That's how the profits would be shared at the end of the year. Partnership, let's take care of another part of ratio, which we call componendo and dividendo. It's called componendo and dividendo. Now, what is componendo? What is dividendo? Now, if A by B is equal to C by D, then if you apply componendo, then it becomes A plus B over B is equal to C plus D over D. And whenever we see that two ratios are equal to each other, we call them, they are in proportion. When two ratios are equal, we call them, or we call it proportion. They are proportional to each other. Now what happens? Componendo is this. So what is dividendo? Dividendo is something like this. A minus B by B is equal to C minus D by D. So if we club in both together, we have componendo and dividendo will give us A plus B over A minus B is equal to C plus D over C minus D. This ratio kind of justifies this action. Now there are two more things which we call alternando. Alternando and invertendo. Now what is alternando and invertendo? Now if A by B is equal to C by D, that means if these two ratios are equal to each other or they are in proportion, we can say that A by C is equal to B by D. This is alternando. That means this comes in here and this goes in there. So it becomes A by C is equal to B by D. Now what is invertendo? Invertendo is if A by B is equal to C by D, invertendo would be B by A is equal to D by C. B by A will be equal to D by C. Now, whenever we look at questions like this, there is one thing we need to be a little bit careful of. That is, like we need to sort of address the question with respect to what it is asking for. Like say, for example, what is the application with respect to these kind of things? Now, say for example, you could get a question that if x is to y, if x is to y is 5 is to 3, then find x square plus y square is to x square minus y square. If x is to y is 5 is to 3, then find x square plus y square is to x square minus y square. So how do we address a question like this? Now straight away, if you look at the stem of the question, we can easily say that x is to y means x by y is equal to 5 by 3. So x by y is proportional to 5 and 3. Now the next step is to get our squares. So I can easily say that x square by y square is equal to 25 by 9. I can say that by squaring both sides. Now I would be using componendo and dividendo. If I use componendo and dividendo together, what will I have? I'll have x square plus y square over x square minus y square. So x square plus y square is nothing but 25 plus 9 over 25 minus 9, which is equal to nothing but 25 plus 9 would be 34 and 25 minus 9 would be 16. Now you can reduce it. It is 17 by 8 and that's our answer. So if we can easily say that if x is to y is 5 is to 3, then x square plus y square is to x square minus y square would be nothing but 17 by 8. And how did we solve the same? We used componendo and dividendo clubbed together. Now, since we have moved into proportion as we had discussed earlier, it's nothing but when two or more ratios that are equal to each other, we call them they are in proportion. So here, let's look at this particular concept which is called mean or mean proportion. This is also called geometric mean. Now, mean proportion is nothing but, say if you have a ratio A is to B, the mean proportion x would be nothing but root over AB. That is, for example, if I say find the mean proportion of 4 is to 9. So basically what will I do? The mean proportion x would be equal to root over 4 into 9. So basically I'm talking about 2 into 3. So the thing is 6. And we can easily write this as nothing but 4 is to 6 is to 9. Or it becomes a continued ratio or proportion. And this is the mean. Now, the next thing which is associated with proportion, of course, after mean proportion, we have this concept which is called the third proportion. Now, what is the third proportion? Third proportion means, like say, if you have A is to B, and we have to figure out what is the extremities when you have the mean. In fact, it's nothing but a variation of this only. So the third proportion y, let us take y in this case, will be nothing but b square by a. Now, say for example, you said find the third proportion of 1:5. So basically it's nothing but y is equal to 5 square by 1, so it's 25. So basically it is 1:5:25, and again if you notice this, like 1 and 25, if you take the product and take out the square root, you will get the mean proportion 5. So basically it's nothing but it is a manipulation of this thing. Like if you square both sides, x square is equal to ab. So what would be like x square is equal to ab? So here if you have to take out any one of them, it has to be x square by a or x square by b. So that's how this thing gets justified. Now let's move into the next thing, which is called the fourth proportion. Now what is the fourth proportion? Suppose if you have a is to b is to c, and you have to figure out what should come next to be in proportion to abc. Now here let us take the fourth proportion to be z, which is nothing but b into c by a. b into c by a is the fourth proportion. Basically, see, if we have something in continuity, like say for example, if it is say a is to b is to c is to z, since we are taking z as the fourth proportion, so a by b is equal to c by z. Now if I take this over here, okay, so what do we have? And if I take z over here, so z is equal to nothing but bc by a. Everything is derivable, and in fact if you follow the rules, you can actually, there's nothing to remember, you can derive it on the spot. Now here if you look at it, let's answer a question related to this. Like say find the fourth proportion of 5:8:10. Now obviously the fourth proportion z would be nothing but b into c, that is 8 into 10 divided by 5. If I do the math, it's coming to 16. So basically the ratio would look like 5:8:10:16. So that takes care of the different forms of proportion. Now I'd like to discuss another question. The question goes something like this. Let's look at this particular question. It's totally based on a continued ratio or proportion. The ratio between the speeds of 3 cars are in the ratio 2:3:4. Find the ratio between the time taken by them to cover the same trip, or the same distance would be a better word, to cover the same distance. Now, here let's look at it this way. Now, what is the relationship that speed has with time? Now, let us look at the formula or the relationship that speed, distance and time have with each other. Speed is equal to distance over time. So that means speed is inversely proportional to time. That means if speed is more, time will be less, and vice versa. So if time is more, speed would be less. So how do we address a question like that? Now it's very simple. Let's take the ratio of the speeds to be 2:3:4, which is already given in fact. Now let us take the LCM of the speed ratio, which is nothing but 2, 3 and 4 has to be 12. Now 2 goes in 12 how many times? It will go 6 times. 3 will go in 12 how many times? 4 times. 4 will go in 12 3 times. So we can easily say the ratio of the time is 6:4:3, because speed is inversely proportional to time. So here what did we do? We took the ratio between the speeds of the 3 cars and the ratio 2:3:4. So what would be the ratio between the time taken by them to cover the same distance? The ratio of the time would be nothing but, if you have to take out the LCM of the speeds, whatever comes out from the LCM, the inverse is basically, we call it the time ratio. Now, if you have a difficulty understanding this concept this way, we can also look at it this way. So, since the speeds are in the ratio 2:3:4, time has to be 1/2:1/3:1/4. Again, you know for a fact that ratio cannot exist as a fraction. So what we can do is that let's take the LCM. Once again, 12, 2 goes 6 times, 3 will go 4 times, 4 will go 3 times. So if you multiply 12 to all of them, this is what we get, and this is what is the time ratio. I hope this concept is clear to you. Now let us talk about another question. Now another question would be something like this. If the ratio between the corresponding sides of any two 2D figures is A:B, the ratio between their areas will be A²:B². Now, looking at the first thing, ratio between the corresponding sides. Now, say for example, if we say that the side of a particular triangle is 3 times or is multiplied 3 times, then what would be the ratio between the areas? Now, here if you look at it, say this could be one triangle and this could be the bigger triangle. And now if this is say ABC and this is say PQR. Now if I say that AB by PQ is 1:3, because the question itself says that if the sides are increased, increased 3 times, then what would be the corresponding areas? Now ABC has become a bigger ABC. In fact, this ABC has been magnified to PQR, or rather, just to make it sound similar, let's look at this as a magnified ABC. So A dash, B dash, C dash. So we can say AB by A dash, B dash is 1/3. So obviously, what will be the ratio between the areas? That could be the question asked. So ratio between the areas is nothing but, we can say AB square by A dash B dash square, which is nothing but 1/9, or we can say 1:9. Similarly, if you could look into a cylinder, say we have a small cylinder and this thing is magnified, say 2 times, magnified 2 times. If it is magnified 2 times, then we'll say the ratio between the volumes, that is V1:V2, would be nothing but, if the ratio, of course, let me frame a question for this first. Let's say that these two cylinders, suppose H1:H2 is 1:2. So what would be the ratio between the volumes? Now in this case, what will I do? Volume 1 and volume 2 would be nothing but, if the other parameters will also expand that way, if the corresponding thing that comes out, we can say that since H1 by H2 is 1/2, so the corresponding volume would be nothing but H1 cube by H2 cube, which is nothing but 1/8, which means it is 1:8. So if you look at it very carefully, what we have done out here is that first we have figured out that if the ratio between the corresponding lengths of any two 3D figures is A:B, the ratio between their volumes, it has to be the cube of the respective sides. Okay, so if the height increases, obviously the other things have to increase, then only this particular thing. The ratio between the sides of two cubes, is 1:2. So what would be the ratio between their volumes? Now in this case, what will we do? Now since the ratio between the sides is 1:2, here we'll say V1:V2 is nothing but 1 cube by 2 cube, so which will give us 1/8. So V1:V2 is 1:8. Okay, so here once again, if you look at it, now if the corresponding sides of two triangles are in the ratio 1:3, then obviously what happens, the ratio between their areas is 1:9. Similarly, if the ratio between the sides of a cube is in the ratio 1:2, ratio between their volumes has to be 1 cube by 2 cube, which is 1/8. With that, we can wrap up ratio and proportion. Hope you could sort of gain knowledge with respect to whatever inputs we provided in this particular session. But then at the same time, there are many applications of ratio. In fact, when we'll be discussing this particular chapter, averages, allegations and mixtures, you'll be exposed to more applications of ratio. For the time being, thank you very much and have a nice day.